Welcome students, I'm Dr. Sima Desai Fernandez from St. Xavier's College, Mapsa, Goa. This program is for the SY-BSc students, subject botany, course code BOC 104, course title Plant Physiology. Title of the unit, Translocation in Phloem, module name, Phloem Unloading, Assimilate Partitioning. Outline of the module is Phloem Unloading, Assimilate Partitioning. Learning outcomes. It explains the phloem unloading, assimilate, partitioning. Introduction. Regulation of photosynthesis and photosynthate utilization is highly coordinated in plants. The products of carbon assimilation or photosynthesis such as hexoses, sugar, starch, etc. that is fixed carbon are called as photosynthetes or photoassimilates or simply assimilates. Photosynthate or assimilate partitioning is the differential distribution of photosynthetic products into sink. A photosynthate or assimilate is the resulting product of photosynthesis. These products are generally sugars. These sugars that are prepared from photosynthesis are broken down to create energy for use by the plant. Sugar and other compounds move via the phloem to tissues that have an energy demand. These areas of demand are called sinks. Example, roots, tubers, stems, fruits and seeds. While areas with an excess of sugars and a low energy demand are called sources. Example, leaves. Many times, sinks are the actively growing tissues of the plant, while the sources are where sugars are produced by photosynthesis, the leaves of the plants. Sugars are actively loaded into the phloem and moved by a positive pressure flow created by solute concentration and turgor pressure between xylem and phloem vessel elements. These are specialized plant cells. This movement of sugars is referred to as translocation. When sugars arrive at the sink, they are unloaded for storage or broken down or metabolized. The partitioning of these sugars depends on multiple factors such as the vascular connections that exist, the location of the sink to the source, the developmental stage, and the strength of that sink. Vascular connections exist between sources and sinks, and those that are the most direct have been shown to receive more photosynthetes than those that must travel through extensive connections. This also goes for proximity. Those closer to the source are easier to translocate sugars to. Developmental stage plays a large role in partitioning. Organs that are young, such as meristem and new leaves, have a higher demand, as well as those that are entering reproductive maturity, creating fruits, flowers, and seeds. Many of these developing organs have a higher sink strength. Those with higher sink strengths receive more photosynthetes than lower strength sinks. Sinks compete to receive these compounds and combination of factors playing in determining how much and how fast sinks receives photosynthetes to grow and complete physiological activities. Assimilate partitioning during vegetative phase. In a vegetative phase of a plant, root, stem and developing leaves are different sinks, and these may be competing with each other for the assimilate. The ratio of assimilate partitioned to these three organs influences the plant growth. And in this stress, the plant may invest more assimilate in developing leaf area to capture more and more light to produce more and more carbohydrates. Since leaves also require water and nutrients, investment in proper root growth becomes necessary. Duration of leaf functioning as sink lasts long for a limited period as soon as it becomes self-sufficient. Thereafter, leaves start exporting and behave as a source. A fully developed leaf may export 60 to 80% of its assimilate to the sink region. When leaves grow mature and senescent, they do not export or import assimilates. Rather, some minerals may be exported out of the leaf before they are shedding. Assimilate partitioning during reproductive phase. During reproductive phases in a plant system, most of the assimilate is translocated to flowers, fruits, and seeds. In monocarpic plants, the demand of assimilate becomes so strong that almost the total assimilate is transported to reproductive organs. As a result, leaf and stem growth ceases at flowering and seed formation. In perennial and polycarpic plants, simultaneous demand of assimilates continue and compete between vegetative and reproductive parts. In such plants, if vegetative growth is increased, reproductive yields are adversely affected. Thus, assimilate partitioning and source-sink relationship determines the growth and reproductive yield of fruits and seeds of the plant. The following factors determine the growth of the organs. First, the strength and ability of the source organ, that is leaf efficiency to supply assimilate to the sink. The strength and ability of the sink organs to draw assimilates from the source. And the third, the efficiency and ability of the translocating system. Summary: regulation of photosynthesis and photosynthate utilization is highly coordinated in plants. Photosynthate or assimilate partitioning is the differential distribution of photosynthetic products into sink. A photosynthate or assimilate is the resulting product of photosynthesis. These products are generally sugars. The partitioning of these sugars depend on multiple factors such as the vascular connections that exist, the location of the sink to source, the developmental stage, and the strength of that sink. These are the references. Thank you.